In the next lecture, we'll study about the delta connection, right? Last lecture, we'll studied about the star connection. Now we'll study about the delta connection. So similarly, we'll mark the line current, line voltage as we have done for the star connection. So this is the delta connection, right? This one is what? R, Y, one is B. So in this case, let's mark the um, voltage first. In this delta connection, there is no neutral. Okay, point we can consider as 1 and 3. So the voltage between R and Y would be VRY, right? Voltage between Y and B, YB, and the voltage between R and B, VRB. Correct? Similarly, we have voltage across 1 and 2 would be V1, 2. Voltage between 1 and 3 is V3, and the voltage between 2 and 3 V2. So now can you tell me which one is the line voltage and the phase voltage? Yeah, L is equal to VRY is equal to VYB equal to VR, right? Similarly, we'll have phase 1, 2 equal to 1, 3. These are all the line voltage and phase. Now, one more thing you need to tell me that VRY will equal to V12, yes or no? Yes, because as you can see that potential across 1 and R and potential across 2 and 5 would be the same. So what we can conclude that line voltage must be equal to the phase voltage, right? In the case of delta connection. Now again we'll draw the delta connection, mark the current. We'll draw the same diagram for the delta, but now we'll draw the current. Suppose this is R, this is Y, this is B. Here the current flowing IR, IY or IB. This one is 1, 3. Okay. So current flowing in 1 and 2 is I12. Current flowing in I13, I13. Current flowing I2 is I2. So what we can conclude that IR, IY and IB are the line current or phase current. They are flowing across the plain wire or across the windings. Across the no, IR, IY or IB. These are the these are the line current. And I13 equal to I12 equal to I. These are the line current or the phase current. These are the phase current. So in this case, line current and phase current are equal or unequal? Can you tell me? These are unequal, right? So we for this we'll have relationship that IL is equal to root IPH, but this time the angle difference between current is minus 30. Okay, clear? So what we conclude in the delta connection that will have same voltage. Same voltage means line voltage is equal to the phase voltage and different current. IL is equal to root IPH, angle is minus 30, right? Now if we'll draw for the star connection, have same current, correct? Same current means IL is equal to IPH and VL is equal to VH and the angle is 30 degree. So this concept you have to use the numerical. Understood? Now one more thing, we'll have power formula that PQS. If you remember, you have studied in the physical phase. P is the active power, right? So active power formula was, can you tell me? Active power formula is I cos phi. Okay. Reactive power formula is VI sine phi. And apparent power formula is only VI, right? If you remember the unit, active power unit is watt, reactive power unit is VAR. AR means volt ampere reactive, and this one is VA. A is volt ampere. Okay, so yeah, okay. This is for the single phase. Okay, I'm telling you for the three phase now. The power is root VL if we want in terms of line. So root 3 LIL cos phi. If we want in terms of phase, then that would be 3H IPH cos phi. Okay. Similarly for Q, have root VL IL sin phi, and that would be H IPH sin phi. Okay. Next we'll have the apparent power, that is L IL and then H IPH. Okay. Understood? So some of the student ask, ma'am, this is the formula for star or delta. So these are the formulas same for the star and same for the delta. No change in star and delta connection. Power would be same whether it would be in star connection or in delta connection. Understood?